Good afternoon and a warm welcome to Power Tech. We're continuing our discussion and short videos on coaxial shunts. This one is a very short episode and we're just talking about some of the issues and concerns about mounting it on a PCB. So how would you mount this on a PCB and why would you be concerned? Well, just to recap, the idea of a coaxial shunt is that it can measure AC signals without introducing much inductance into the circuit. So we're talking fractions of a nanohenry here, and also we're looking at rise times of maybe, I would say, probably 1-2 nanoseconds rise time we're trying to measure. So that would be with like a power switching device, typically like a power MOSFET perhaps, or an IGBT or a GaN device, where they're very interested on how much energy is dissipated as the device turns on. And this is a great thing to use to do that. Compared to Rogowski coils, which are beginning to give this a run for the money, but they kind of max out around about 50 megahertz. This goes into the hundreds of megahertz, so clearly it has some significant advantages over a Rogowski coil. But bear in mind, it's always a case of horses for courses. This doesn't have an isolated output. It has an output on that BNC there, but clearly depending on what your circuit's doing, you may need to isolate or be mindful of the common mode or the ground loop effects that could come into play when using a device like this. Now, the main thing here is to think about some of the geometry of mounting that onto a PCB. And typically, a good starting point is to mount it vertically. Because when you think about it, depending on what polarities, what planes are close to this device, it's kind of good to get this out of the way. But that's only a rule of thumb. I've seen people mounting them down in that orientation and getting good results, and that might be because they deliberately got rid of their planes on the board in that area, so this can't introduce parasitics. But standing it up is certainly a good way of doing it, and there's nothing to stop an engineer moving it into different orientations and repeating the test several times and looking at the difference. So it's really that simple. Some of the shunts that we make are even intended to be mounted exactly like that. So they have the legs sticking out, the current feed terminals, and then on the top there they have two legs instead of a BNC, so you can basically build it into a power board or whatever equipment you're trying to measure. So once again, that's a coaxial current shunt, also known as a current viewing resistor, CVR, and these are really becoming more and more important in the power electronic world because of the high speeds everybody is trying to achieve. So I hope that's useful. Once again, my name's Derek Luce at PowerTech. You can contact us on info@powertechus.com or info@powertechuk.com. All the best. Bye.